Tonight, when the sun goes down, you're going to flip a switch. Light will flood the room and you won't think twice about it. But for 99.9% of human history, that switch didn't exist. When the sun set, the world went dark. Total dark. And something in your body still remembers that. You call it a fear of the dark. But that's not quite right. You're not actually afraid of darkness. You're afraid of what darkness hides. Your eyes go wide. Your ears sharpen. Your heart rate climbs before your mind even catches up. Why does a species that built cities, cured diseases, and reached the moon still flinch at an empty hallway with the lights off? The answer starts almost 2 million years ago, on the open grasslands of East Africa. Your early ancestors were not the strongest animals on the savanna. They were not the fastest either. Compared to a lion or a leopard, an early hominin was slow, soft-skinned, and poorly armed. During the day, they had one major advantage: eyesight. Daylight let them spot predators from a distance, read the landscape, and plan their movements. At night, that advantage disappeared completely. Anthropologist Sarah Blaffer HRDY has spent decades studying primate vulnerability, and her research points to something striking. Early humans were, for most of their evolutionary history, prey, not occasional prey. Regular, hunted, eaten prey. Big cats, hyenas, and other nocturnal predators had excellent night vision. Your ancestors did not. So night became the most dangerous stretch of every single day. Think about what that means for a species over hundreds of thousands of generations. Every night, for millions of nights in a row, individuals who felt calm in the dark were more likely to wander from the group, more likely to miss the sound of a predator approaching, more likely to die before passing on their genes. The anxious ones survived. The relaxed ones didn't. Generation after generation, natural selection was quietly running an experiment. And the results are still living in your nervous system today. This is where the science gets specific. Deep inside your brain sits a small almond-shaped cluster of neurons called the amygdala. It's your threat detection center. It doesn't wait for proof of danger. It reacts to the possibility of danger, instantly, before your conscious mind has time to evaluate anything. Researchers like Joseph Ledoux, who has spent his career mapping fear circuits in the brain, discovered that a threat signal can reach the amygdala through a fast, low-resolution pathway that bypasses higher reasoning almost entirely. That's why you can jump at a shadow before you even know what you saw. Darkness is the perfect trigger for this system, not because darkness itself is dangerous, because darkness removes information. Your amygdala isn't built to calculate probabilities. It's built to prepare for worst-case scenarios when the data runs out. And when you can't see, the data runs out fast. Here's the twist most people never think about. Fear of the dark isn't really about darkness at all. It's about uncertainty. Psychologists have found that humans are consistently more distressed by ambiguous threats than by clear, defined ones. A wild animal you can see is frightening, but it's a known problem. Your brain can assess it, plan around it, decide whether to run or freeze or fight. A rustling sound in pitch blackness is a different category of fear entirely because your brain can't rule anything out. It fills the gap with worst-case guesses. A branch becomes a snake. A creak becomes a footstep. Your imagination isn't malfunctioning. It's doing exactly what it evolved to do. There's a reason this shows up so early in life too. Developmental psychologists have tracked fear of the dark in children as young as 2 years old, well before kids have been taught ghost stories or watched a single horror movie. That timing matters. It suggests this isn't a fear you learn from culture. It's a fear that culture merely gives shape to. The blueprint is already there. Stories about monsters under the bed didn't create the fear. They gave a name and a face to something your brain was already primed to expect. Consider how differently your senses behave once the light disappears. During the day, vision does most of the heavy lifting. It's fast, detailed, and reliable. At night, your brain has to lean harder on hearing and touch, senses that are slower to process and far more prone to misinterpretation. A 2013 study on nighttime anxiety found that people report significantly more intrusive, threat-related thoughts after dark, even in completely safe environments like their own bedroom. Your body isn't malfunctioning when this happens. It's running software that was optimized for a world that no longer exists. And this is where the story becomes almost strange to sit with. You live in a world of streetlights, smartphones, security systems, and locked doors. Statistically, you are safer at night than any human who has ever lived before you. And yet the oldest part of your brain hasn't gotten the memo. It still runs the same threat calculations your ancestors ran on the savannah 2 million years ago. Evolution moves on a timescale measured in tens of thousands of years. Technology moves on a timescale measured in decades. Your instincts simply haven't caught up to your environment. This mismatch shows up in ways you might not expect. Have you ever noticed that a house feels different at night, even though nothing in it has physically changed? Same walls, same furniture, same locked door. But somehow, the shadows feel heavier once the sun goes down. That's not your imagination playing tricks on you for no reason. That's ancient neural circuitry treating darkness exactly the way it was built to. There's an evolutionary reason this circuitry has been so difficult to switch off. Fear that keeps you alive doesn't need to be pleasant. It just needs to work. A false alarm, jumping at a coat rack that looked like a person, costs you almost nothing. A missed real threat could cost you your life. So evolution built a system that's heavily biased toward false alarms. It would rather make you flinch 1,000 times at nothing than miss the one time something is actually there. That bias is not a flaw. It's the entire design principle. Modern research on sleep and anxiety adds another layer to this. Neuroscientist Matthew Walker's work on sleep and the brain has shown that the amygdala becomes measurably more reactive when you're tired, and less regulated by the parts of your brain responsible for rational thought. That's part of why fear of the dark often intensifies right before bed, when your body is winding down and your prefrontal cortex, the part that would normally talk you out of irrational fear, is powering down right along with it. You're at your most vulnerable to imagined threats at exactly the moment your brain is least equipped to talk you out of them. So what does this mean for you, lying in bed tonight, glancing at a closet door that's open just slightly too wide? It means you're not broken, you're not irrational, you're not a child who never grew out of something you should have outgrown. You are carrying a warning system built by millions of years of nights spent as prey. It kept your ancestors alive long enough to become your ancestors in the first place. Every single one of them made it through enough dark nights to pass their genes forward. You are, quite literally, descended from the ones who stayed alert. The dark hasn't changed, but you have. You built lights and locks and cities that never fully go quiet. You built a world your amygdala was never designed for, and still, some nights it forgets. It runs the old program anyway. Tonight, when the sun goes down, you're going to flip a switch. And in that half second before the light comes on, in that tiny window of uncertainty, you'll feel it. Not weakness, not superstition, just 2 million years of survival, still running quietly in the dark.